Hello everyone, I welcome you all to this session. In this session, we are going to discuss all famous CPU scheduling algorithms. So let's start the discussions. There are generally two types of CPU scheduling algorithms, as I have mentioned here, preemptive CPU scheduling algorithms and non-preemptive CPU scheduling algorithms. So what is preemptive CPU scheduling algorithms? As I have written here, in preemptive CPU scheduling algorithm, a running process can be interrupted by the system, or you can say scheduler, and the CPU control can be switched from the running process to some other process. So that is preemptive case. But in case of non-preemptive CPU scheduling algorithm, once a process gets the CPU control, the process cannot be interrupted, right? So process either will finish its lifetime or process may go for blocked state because of some requirement of IO, right? So in that case, the CPU can be switched. Okay. So your preemptive scheduling algorithms they provide us the better CPU utilization because there is a flexibility to preempt a process. So in case any higher priority process comes in the system, that can be scheduled right immediately at that moment. But in case of non-preemptive CPU scheduling, the running process cannot be interrupted, but it provides the better process reliability because interruption is not possible, right? There are different types of process, or you can say CPU scheduling. The very first is first come first serve. It falls under the category of non-preemptive CPU scheduling. Then next is shortest job first. It falls under both the category. So there is a version non-preemptive SJF and preemptive SJF. Preemptive SJF is also considered as SRTF, shortest time remaining first. Shortest time remaining first is the preemptive version of SJF or shortest job first, right? Then priority scheduling. Priority scheduling also, there are two types of priority scheduling we can implement: preemptive priority and non-preemptive priority. So based on the priority, the preferences will be given. Then round robin scheduling. In round robin scheduling, the processes will arrive in the ready queue. Whatever the processes will be in the ready queue, the CPU will be allocated in a circular manner for a certain duration of time, right? And then multi-level queue scheduling. Multi-level queue scheduling is like a slightly different kind of scheduling in which the ready queue will be created in multiple levels according to the priority of the processes. So in a system, if there are n number of priority level, the process, one process is having, let's say, priority 0, then 1, then 2, and so on. So different priority processes will arrive in different queues. Okay, we will discuss this later. In multi-level feedback queue scheduling, there will be multiple levels of the priority queue, or you can say ready queue is divided into multiple level of priority queue, and the priority of the process can be updated according to some criteria or condition. But in case of multi-level queue scheduling, whenever a process arrives, there is a priority value and it is fixed, or you can say static in nature, it cannot be updated, right? Then fair share scheduling. Fair share scheduling generally will be implemented when there are multiple users initiating multiple processes. So a process will have some owner, or you can say the initiator or user. So in multi, or you can say fair share scheduling, the processes will be grouped into n number of group, you can say, according to the number of users. So if there are 3 users initiating different processes, the process will be separated into 3 groups, and system allocates the resources equally for each group, right? Then the different schedulings can be incorporated after that. Then real-time scheduling algorithms. So as we have already discussed in types of operating system, one of the very famous and prominent operating system is real-time operating system. In such kind of systems, every process has a deadline, right? So in real-time CPU scheduling, the decision will be made by considering two things. One is the priority of the process and another is the deadline of the process. Okay, so in each of these CPU scheduling algorithms, the priority will be decided based on certain criteria. So in priority scheduling, priority is given as a criteria. In first come first serve, arrival time will be the criteria. Like, so there are different criteria. Let's see these algorithms in detail. So the very first algorithm is first come first serve. So what happens in first come first serve, that once a process arrives in ready queue, there is the arrival time. So I have discussed in the previous lecture or session, there is arrival time, required burst time, and number of times associated to the process. If you haven't gone with that, you can check that. I'll give you in the description, right? So the very first step of the FCFS or first come first serve algorithm is, when the process arrives, it will be added in a ready queue. Okay, and that moment we considered as arrival time, when the process arrives in ready queue. The ready queue is a list of processes that are waiting to be executed. So they are waiting for CPU control to be switched, right? Then the process scheduling will be done. So the scheduler or CPU selects the first process from the ready queue, which was arrived very early in the ready queue, and allocates the CPU to it, and select the process and starts executing. So whatever the process will be selected, it is start executing after that. Then once the process completes, then the record, or you can say the PCB and other thing which was loaded inside the queue, it will be deleted, right, from the system. And these steps will be continuously repeated. So every time a process will be picked based on the arrival time from the ready queue, and then that process will get the CPU control, then execute, finish it, and then next time the same thing will be done. So this is your first come first serve. The next scheduling is shortest job first scheduling. In this, the criteria of selection of the process from the ready queue is the required CPU cycle or required CPU burst. So if a process is requesting less number of CPU cycle, the system will allocate more priority, or you can say scheduler will give them the more priority or more preference than the other. Those are requesting more CPU cycle, right? So these steps like process arrives. So when a process arrives in the system, its burst time is estimated and it is added to the ready queue. So this estimation, because here the decision will be made based on the required CPU cycle, or we say the burst time, as I have discussed in the previous session. You can check what is the meaning of burst time or execution time or required CPU cycle. So based on the burst time, required burst time, the process will be selected from the ready queue. Now this burst time, actually it will be an estimate for the next cycle, right? So that is required. Then once the CPU will select based on the required CPU cycle or burst time, then the CPU will be allocated to the process which is in ready queue and requesting the least CPU cycles or CPU burst. Then the process will execute, and because we are discussing here non-preemptive SJF, so when the process will complete its execution, it will remove from the ready queue, and then the next process will be picked up from the ready queue, right, based on the shortest required CPU burst. And then these steps will be repeated a number of times until and unless all the process will finish their execution. So there is one challenge in this. When we will solve the numerical, you will understand. Accurately estimating the burst time, it is challenging, can be challenging. So I highlight this. And if the estimates are incorrect, in case the estimated burst time will be incorrect, the scheduling preference, or you can say the performance will be suffered, right? So we will discuss it later. Right now you just remember what are these steps. Okay, in the shortest job first, process arrives in the ready queue, scheduler picks the process or give the preference to the process which requests the least CPU cycle, and then the CPU will be allocated to that process, and that process will finish its lifetime, right? Now the next is priority scheduling. So in priority scheduling, the decision or CPU allocation will be done based on the priority value, right? So scheduler process based on their priority level. First step is process arrival. So the process will arrive. When the process will arrive, it will have an associated priority level. So it will arrive in the ready queue with an associated priority level or priority value. Then the process scheduling will be done. So if a process is having higher priority, it will get CPU early. So the CPU select the process based on the higher priority from the ready queue and allocate the CPU to it. The process start executing after that. Then once the process completes, because right now we are considering this CPU scheduling is non-preemptive. So once the CPU will be allocated to the process, then the process will finish its lifetime, because non-preemptive case we are considering right now. And after the completion, the process will leave from the ready queue, it will be removed, and then the steps will be repeated from the very first thing. So again, the new process which is having the highest priority will be selected and execute, and the same thing will keep on going on. Then the next is round robin. Round robin falls in the preemptive category. So the running process can be preempted and the CPU can be switched to the new process, right? Like this. So it allocates the CPU to processes in a cyclic manner. A cyclic manner, you remember. So if there are a number of processes, let's say you are having a number of processes like P1, P2, P3, and let's say Pn. So if all are in ready queue, then the CPU will be allocated for a certain duration of time that we consider as time quantum. So first time quantum will be allocated to P1, then P2, then P3, then and so on, then Pn. And after Pn again, the chance will be given to the P1. So it is a kind of time sharing kind of system. Every process will get the equal CPU time. So it is a kind of fair scheduling. Okay. So these steps are: process arrives in the ready queue and it will be added in the ready queue, then process scheduling will take place. So the first process in the ready queue will allocates the CPU for a fixed time quantum. Fixed time quantum is important. Every process will get at max that much of time. So maybe certain milliseconds you consider, right? Then process will be preempted after the time quantum gets over. So if the time quantum of 2 millisecond, after 2 millisecond, if P1 was executing and if P1 has not finished its execution, then also P1 will be preempted and the CPU will be switched to P2, right? And so on. And if P1 was not finishing after Pn, again P1 will start executing from that moment, right? And it will keep on going on. So if P1 will be preempted, it will be again added into the ready queue. So next time the same thing will be happening and this process will be repeated until and unless all the process will finish its lifetime. So that is round robin, right? And the next is okay, so you discuss few of the points related to round robin. Round robin is very important algorithm. In this, processes are executed in a cyclic manner that I have already discussed. Each process getting a fixed time slice of the CPU, equal time slice every process will get. Each process gets a fair share, as I told you, of the CPU time, and that's no process is stopped. No process will be stopped because every process will get the CPU cycle equally. Okay. The performance of the round robin algorithm can be affected. So that is an important point. The performance can be affected by the size of the time quantum. So if you vary this time quantum, the performance will vary. So if time quantum is very large, in that case, there will be low CPU utilization. So the overall throughput will be less. If a time quantum is very small, then it may lead to high overhead of context switching, you can say, or process preemption. So because after time quantum we need to switch the process or CPU control to another process, the previous one need to be, you can say, preempted, then the context switching and so on. So unnecessarily the time wastage will be there in terms of context switching, right? So this is the drawback also. When we solve the problem on this, you will get to know that. The next CPU scheduling is multi-level, multi-queue or multi-level queue scheduling, CPU scheduling algorithm. So multi-level CPU scheduling algorithms, as I have already told you, it separates the processes into multiple priority queue, each with its own scheduling algorithm. So there are different level of queues, and every queue may incorporate different scheduling algorithm, right? So it is like that. There can be different scheduling algorithm, right? And number of levels of queue. So the very first level, let's say the priority 0. So whatever the process will be having priority 0, they will arrive in this, then priority 1 and so on. Then let's say some priority level n-1 will be here. So the process will be that priority level, n-1 will arrive, right? So this is the n priority. And scheduler will pick up the process from the top level. Once it is empty, then it will start picking from the next level and so on and so on. And this will be keep on happening on different level of queue. Different algorithm can be applicable, can be applied. So let's say the very first level FCFS is running. In next level, there may be round robin is running and so on. So it is possible in this, right? It is mentioned. And the same steps will be repeating until and unless every process will finish its lifetime. Okay. In this scheduling, there is one problem, you can say. Some of the process, those are at very low level, they arrived at nth level of priority. They may get CPU after a very long duration of time. You can say starvation problem can be there. Starvation can be there, right? So to deal with this problem, there's another CPU scheduling introduced that we consider multi-level feedback queue scheduling, MLFQ CPU scheduling algorithm. In this, one extra step is there, which we consider as priority adjustment. So rest of the steps are almost similar to the multi-level queue scheduling. In this, one thing is extra. Priority value can be incremented based on certain criteria. So like based on the resource usage or based on the IO operations and number of other criteria, based on that, the priority can be incremented. So a process can be shifted from one level of queue to another level of queue. So in this, we can deal with the starvation. Starvation will not happen in such scenario, right? And this mechanism we consider as aging. Okay, so remember two terms, starvation and aging. These are important terms. So one is starvation and another is aging. Okay, so aging is one of the mechanisms which solve the problem of starvation in multi-level queue scheduling, right? And these steps will be repeated. Now the next is fair share scheduling algorithm. As I told you, aims to distribute CPU time fairly among the different users or processes. So in a system where there are multiple users, this fair share scheduling algorithm will be helpful. So the very first step in this fair share scheduling is grouping. It groups the running or available process in the ready queue according to their ownership or the user. And then it start allocating the resources group wise, right? So if there are 3 users or 4 users or 5 users are initiating the processes, there will be equal number of groups as available users, right? So if there are 5 users, there will be 5 groups. And for each group, the system will try to allocate equal number of resources, or you can say equal amount of CPU time, right? And then process scheduling will be incorporated. So the process within the each group will be scheduled based on any specific algorithm, right? So maybe round robin or any other algorithm can be applied, right? And then there is one step in which the system will check the resource utilization by that a particular group. So if the allocated resources is not being utilized by a particular user's processes, then the resource allocation can be changed also. So there is a provision of that. So that is considered as feedback. right? So based on the feedback, the resource allocation can be shifted or changed from one group to another group, right? Then the next CPU scheduling algorithm we consider as real-time scheduling algorithm. So in real-time scheduling algorithm, allocates the CPU to real-time processes with a specific deadline and priority. So as I already told you, right? In real-time systems or real-time operating system, every process has associated deadline and its priority also. Now the steps are, when the process arrives, it will arrive with some priority and deadline. This is one of the extra parameter in real-time systems. In normal system, process arrives. Process may have a priority or process has a priority, but process doesn't have the deadline in normal system. But in real-time system, deadline is must. Then when it arrives, it will be added in the ready queue and then process will be scheduled. But the scheduling criteria is very important here. First is the process of highest priority and earliest deadline. So if a process is having highest priority, and then the second parameter will also be compared, the earliest deadline, highest priority, earliest deadline, the combination. Based on the combination, the scheduler will decide which process need to be scheduled. We will solve the problems on this also. Then the processor will be allocated to the process which has been opted or selected by the earlier stage, and then process will execute and completes. Once it will complete, again the steps will be repeated. The process will be picked based on the priority and the deadline. So this is the real-time scheduling algorithms. I hope this discussion will help you to understand the functioning and the different steps of this. In next session, we start solving the numerical problems on this, all these CPU scheduling algorithms. Thank you everyone for connecting. See you in the next session.